The objective of this lesson is to find the areas of regular polygons and triangles using trigonometry. So we're going to use the formulas that we've been using, like, the area of a regular polygon is 1/2 the apothem times the perimeter. But we're going to be using trig to help us find those lengths. So you can use trigonometry to find the area of a regular polygon when you know the length of a side, radius, or an apothem of that regular polygon, because you can use trig to find the other parts that you need. In this diagram below, it asked what is the apothem in the diagram below. The apothem is the altitude of the isosceles triangle that's drawn there in red. The apothem bisects the central angle of that polygon, and it bisects the side of the polygon. So we're going to use all of those facts when we're going to be finding the lengths that we need to use in our formulas. The other formula that we're going to be using specifically is to find the area of a triangle. We can use trig to find the area of a triangle when you know the length of two sides of the triangle and the included angle that's in between those two sides. So that's why this is called the area of a triangle given side angle side, because you have two side measurements and the angle that's included in between. So the area of the triangle is going to be half of the product of the lengths of the two sides that you know and the sine of the included angle that's in between. So we have the area of triangle ABC here is going to be 1/2 if we know the length of side B and C. Then we're going to multiply that times the sine of angle A. So to help you kind of remember this formula, it helps to know where it comes from. It's actually just the formula for the area of a triangle. The area of a triangle is 1/2 the base times the height. But if you look at this triangle, the height is going to be from the perspective of angle A. Okay, from the perspective of angle A, the sine of A, angle A, is going to be opposite over hypotenuse, which is that height over side C. So if we multiplied both sides by C, then the height is going to be C times the sine of angle A. So if you substitute that in for that height in our normal formula for the area of a triangle, 1/2 the base times the height, then that's where you get this formula. The area is 1/2 the base, which is B in this triangle, base B, times side C times the sine of angle A. So we just substituted C times the sine of A in for the H of the height. So this is where this formula is. Let's take a look at some problems to use this. Problem 1, we're finding the area of a regular octagon. Octagon has 8 sides. So let's look at what it's given us. It's given us the length of one side. So let's draw in some of our other parts. The center of the octagon, and then we'll draw in a couple of radii from that center, and then the apothem is going to be the perpendicular distance from the center to that side. So that's our apothem. Now these radius, the radius are all congruent, so those two sides are congruent. You need to know the measure of this angle, this central angle for this octagon. So the central angle, remember, any polygon, the total number of degrees inside here it's like a circle, so it's 360 degrees. So 360 degrees divided by 8, because we have 8 of these triangles inside this octagon, is going to be 45 degrees. So that central angle is going to be 45 degrees. But we only need half of that central angle for one of these right triangles that we have marked. So half of this angle is 22.5 degrees. Half of 45. Now remember, since this is an isosceles triangle that we've drawn, then this side is bisected. So half of 7.5 is 3.75. So each one of these is 3.75. Each of those bases of the right triangle that's drawn. So this is where we're going to use trig to find the length of that apothem, because we need the length of the apothem for the formula that we're going to use for 1/2 the apothem times the perimeter. So looking at this from the perspective of the 22.5 degree angle, we have the opposite side is 3.75, and the apothem that we need is the side that's adjacent to the 22.5. Okay, so we have opposite over adjacent, which, if you remember your SOHCAHTOA, opposite over adjacent is going to be tangent. So we're going to set up tangent of 22.5 degree angle is equal to opposite over adjacent. Opposite the 22.5 degree angle is the 3.75. And then adjacent to the 22.5 angle is the apothem that we need. So if I want to solve for the apothem, if you remember that we can switch the extremes on this proportion to solve for A. A is going to be 3.75 over tangent of 22.5. Okay, so now we can use that. I'm not going to, you could put that in your calculator and get a decimal value for it, but I'm not going to do that because that might give us a rounding error if we try to round that value at this point. So I'm just going to take the area formula, which is for a regular polygon, 1/2 the apothem times the perimeter. And we're going to put this whole value right here in. We're going to substitute that in for the A. So we have 1/2 times 3.75 divided by a tangent of 22.5 times the perimeter of this octagon. Remember that perimeter is the number of sides times the length of a side. So the perimeter is going to be, we have an octagon, so it's 8 sides. And then the length of a side is 7.5. So I'm just going to put that up here for the perimeter. We're going to put 8 times 7.5. And then plug that into your calculator, and you are going to get approximately 271.6 centimeters squared. In problem 2, we're finding the area of a regular hexagon. This particular hexagon is a gazebo at a park. It has a floor shaped like a regular hexagon with a radius of 6 feet. So the radius goes from the center of the hexagon to the vertex of the polygon. That is 6 feet. What's the area of the hexagonal floor to the nearest square foot? There's a couple of ways you can do this. Since it is asking us to use trig in this lesson, we will use trig for this problem. If I look at this triangle, remember with a hexagon, with any hexagon, there are 6 equilateral triangles inside. So if I draw the apothem, since these are equilateral triangles, this is a 60, 60, and then this top angle was 60 as well, but so half of this is 30. So you have a 30, 60, 90 triangle, and we could use that as well, and it would be a whole lot easier, but and we will look at that in a minute. But let's look at it with trig, okay? So we need to find the length of the apothem, and we need to know the length of this side at the bottom, but since it is equilateral triangle, we know that this is 6. All 3 of those sides of that triangle are 6. So if that side is 6, and I know that this is a 60-degree angle, then how can we use that? If it's 6, each one of these it's bisected into 3 and 3. We could also look at it that way. So there's lots of options that we have here to do this. But so from the perspective of the 60-degree angle, we'll just go that way. The apothem is the opposite side from that 60, and the 6 is the hypotenuse. So let's look at it as the sine of 60 is equal to, opposite is apothem, and your hypotenuse of that is 6. So to solve for the apothem, you'd have to multiply both sides by 6, and your apothem is going to be 6 times the sine of 60. So you should have what you need now to go into, your formula for 1/2 apothem times the perimeter, because you got 1/2 6 times the sine of 60 times your perimeter is going to be, there's 6 sides and each of them has a length of 6. So perimeter is your number of sides times your length of a side, 6 times 6. And that should give you approximately 94 feet squared. Now, an easier way to me to do this would have been to use the special triangle. The fact that you have a 30, 60, 90 triangle here, the hypotenuse was 6, so the short leg was 3, and your apothem had to be your short leg times the square root of 3. So the other way you could have worked this would have been your area 1/2 apothem's perimeter, 1/2 your apothem is 3 times the square root of 3, and then your perimeter is still 6 times 6. But if you put that in your calculator, you're still going to get 94, approximately 94 feet squared. So you have several choices of how to do this problem, but using the sine method is what they wanted to do, so that's what we did there in red. Let's go on to problem 3. In this last problem, we're finding the area of a triangle when we know two of the sides and the angle that's included in between. So we can use that side angle side triangle formula that we were given. So the area is going to be half of the product of the two sides that we know times the sine of that included angle that's included in between them. So if I wanted to mark these, I would mark this triangle ABC, and the sides that we have are B and C. So plug that in the formula. You got half. Side B is 12. Side C is 8. Times the sine of 36-degree angle. Once again, as a reminder, be sure when you're doing these problems that your calculator is in degree mode, because this is what this lesson is expecting it to be in, is degree mode, in order to get the correct answer for this, because it's 36 degrees. So plug that in your calculator and you're going to get approximately 28.2. And that'll be in centimeters squared.